Hello and welcome to Diplomatic Derivatives. In this series of lectures, we have started with applied mathematics, starting with the vector algebra portion. Now, in this portion, we have already done two videos, first explaining the definition of a vector, and second, we talked about the position vector. So, in order to move forward, first of all, make sure you're clear with the concepts of what a vector is and the concept of a position vector. For that, make sure you watch the previous two videos. The link will be given in the description box below. Now we move on to vector addition, vector subtraction, and scalar multiplication. So let's see how do we add vectors. There are two main ways to add vectors. Now what are those? Number one, the graphical method, and number two, analytical method. Graphical method is head to tail method, the most famous, the most common method which is used to add vectors, and also the analytical method, which is a very simple method to add vectors. We'll see step by step how to perform both of these operations. Number one, the graphical method. So whenever we are performing the head to tail rule, make sure that we have x-axis and y-axis drawn in front of us. So with the help of this axis, we are able to understand how we perform the head to tail method. Okay, so also in the future exercises, we will be performing different questions. We'll be drawing the x and the y axis in front of us at all times, so it is easier, be it the analytical method, be it the head to tail method, whatever kind of vector questions will be given, we will be drawing the x and y axis. All right, so how do we start? First of all, draw the first vector. Now in the previous videos, we have already done vector notation, so make sure you watch those. What does the point A means? Point A means that this first value is on the x-axis and the second value is on the y-axis. Okay, so the first point 2 becomes 2i. So when we write the point in the form of a vector, how do we write? We write 2i, which is a unit vector, show the direction of x-axis, minus 1, so it becomes minus j, which is the position unit vector for y-axis. Okay, so this is the vector notation from a point. Okay, so whenever a point is given, you will write the vector notation. All right, now you have to make that vector. In the head to tail method, first step is start the vector from the origin towards the point. Okay, that's the first step. So point here is 2 minus 1, so 2 on the x-axis and minus 1 on the y-axis brings us to the fourth coordinate. All right, here we have the vector. Step number 2. The second vector will be placed on the tail. So the tail of the second vector, this is the second vector, tail of the second vector is placed on the head of the first vector. So it's like continuing. All right. So your first vector from the origin, second vector starts from the head of the first vector. All right, towards the point. So it's 6, 3. So 6 on the x-axis, 3 on the y-axis. You get the second vector. This lies in the first coordinate. Now, what is the addition of both of these vectors? The addition is the resultant vector. Now, the vector from the tail of the first to the head of the second is the resultant. Tail of the first to the head of the second. That is our resultant vector. Simple. This is the head to tail rule. All right. So it's a very easy method. We'll be performing different exercises, so it will be made much more clear. It's already very clear. So we'll be moving on to the next method of adding vectors. Second is the analytical method or the component method. Again, very easy. Here also we have already drawn the x-axis and the y-axis. Okay. Now we have the first point, which is 2, 3. A is equal to 2, 3. So 2 on the x-axis, 3 on the y-axis brings us to the first coordinate, and that's the vector. Second is point B. Now, unlike the first method, that is the head to tail rule, unlike that method, here we will draw the second vector also from the origin. Okay, not from the head of the first vector. We will draw it from the origin itself. So both the points draw from the origin. Here there's just a slight mistake. Point B is minus 1 and 4. So here I wrote 1 and 4. It's basically minus 1 and plus 4. Okay. So this is minus 1 on the x-axis and 4 on the y-axis. That's the second vector. All right. Now, how do we add them? C is equal to A plus B. So your vector, again writing the point in the vector notation. 2i plus 3j plus minus I plus 4j. So what do you do? add the corresponding components of the vector. So the corresponding components are 2i corresponds with -i and 3j corresponds with 4j. So 2i corresponds here and 3j corresponds here, right? So in this manner you will get 2 minus 1i plus 3 plus 4j. Alright, 2 minus 1 becomes 1, so you get I, and 3 plus 4 becomes 7, so you get 7j. Now the question is in the form of points, right? Therefore your answer must also be in the form of points. So from the vector you will make points. It's simple. I is just 1, right? So you get 1 here, and 7j becomes 7. So you have just converted, since here in the first step from the point you went to the vector, right? Here from the vector you go to the point. Alright, so that's how you will perform the analytical method. Again, very simple, just add the corresponding elements. In case of 3D, you will also be having another point, which is what? Which is Z. So do the similar thing, just add the third one as well. So here it will be also a3 plus b a3i plus b3i, whatever the notation is. I just can't remember right now. It's the same thing, just adding the corresponding thing. So you, in place of just 2 3, let's suppose you have another number 4, so you will have 2i plus 3j plus 4k, right? Also in place of minus I plus 4j, you will also have minus I plus 4j plus 6k. So that 4k from here and 6k from here, right? So it will be 4 plus 6 with k. Alright, so it's the same thing, just adding the value of k as well. So that's the analytical method for addition. Clear? Now we move on to subtraction. Now subtraction is, there's no difference, there's just one slight difference, which is this difference in direction. So what you do is C is equal to A plus minus B. Okay, so that minus B, what is this minus B? Minus B is the change in direction of B. So magnitude of B remains the same. What's the only difference? Direction changes. So first it was minus 1 and 4. Now it becomes 1 and minus 4. Okay, so these values are going to change. Okay, the direction changes. So now your vector goes in the opposite direction. It will be 1 on the x-axis and minus 4 on the y-axis. So what will you do? Performing the same operation, just changing the direction. So A, which is 2 3, plus minus B, which is now 1 and minus 4. Add them, you get 2 plus 1 is 3, and 3 minus 4 becomes minus 1. Alright, so that's your subtracted vector. Alright, this is how you perform vector subtraction. Now, not just this way. So basically what you're saying is graphically subtracting a vector means reversing its direction and then adding. Okay, simple. Now, another thing that we need to remember is in subtraction, let's suppose you have a vector OA, which is 2 3, and OB, which is minus 1 and 4. Okay, OA and OB. Now this is what we need to understand. AB is equal to, now what is vector AB? Vector AB is from the head of A to the head of B, right? What is this vector? You have one vector OA here, you have another vector OB here, right? From A to B there is a vector which is AB, right? From A to B. Okay, how do you find that vector? The formula is OB minus OA. Okay, so you subtract this vector from this. That's how you get AB. Alright, how do you do that? What is OB? Minus I plus 4j minus, you have 2 3, which is 2i plus 3j. Okay, so now you will subtract. You will have minus I and minus 2. So you get minus 3, and 4 minus 3 you get 1. So you have minus 3i plus j, and the points are now minus 3 and 1. Alright, this is a formula that you need to remember. So it is AB is equal to OB minus OA. Okay, that's a vector from A to B. All right. So from this same thing, you get another thing. What do you basically get? What is OB? OB is you take OA on the other side, so it becomes OA plus AB is equal to OB. So by this formula, you will be able to solve any of these, right? So if two are given, you can find the third one. Now this is particularly important when we are performing the exercises where we'll be given two vectors and you have to find the third one. So you'll be using this formula. So make sure you remember AB is equal to OB minus OA. All right. That's for the vector addition and subtraction. Now we move on to the next concept, which is very easy concept. Again, what is a scalar? A scalar is a quantity with only magnitude, no direction. As we saw in the first video as well, vector is something which has magnitude and direction. Scalar has only magnitude, no direction. Examples include temperature, mass, time, and speed. What is scalar multiplication of a vector? When a scalar multiplies with a vector, it changes the magnitude of the vector, but not its direction unless the scalar is negative. So what we're saying here is a scalar when multiplies with a vector, it will change the magnitude of the vector. Since scalar does not have a direction, it only is about magnitude. So when we multiply a scalar with a vector, the magnitude of the vector increases. If it is a negative scalar, let's suppose -2, -3 or anything like that, in that case the direction will be reversed. Okay. So if A is equal to x1i plus y1j and k is a scalar, then Ka will be equal to kx1i plus ky1j. So k multiplies with both the values. Okay, we'll see one example as well. Okay, also effects. If k is greater than 1, vector length increases in the same direction. So if we have k, for example, 2, so the value the vector will be double its size. Okay, if k is 3, it triple its size. The vector magnitude increases, the length of the vector increases in the same direction. If 0 less than k less than 1, so if k is less than 1, okay, vector length decreases but in the same direction. So 0 less than k less than 1. So if you have any values from 0 to 1, okay, in that case what happens? The vector length decreases in the same direction. All right. If k is less than 0, now you have something which is less than 0. The direction reverses. All right. So we will see one example here. We will see the example of the first one. Let A is equal to 3i plus 4j. So we have 3 on the x-axis, 4 on the y-axis. All right. K is equal to 2. So what will happen? K is 2. It's greater than 1. So length of the vector will increase. So that's we see here the length of the vector has increased. It has become double the original vector. Okay, so then 2a is equal to 2 into 3, which is 6, and 2 into 4, which is 8. So you get 6i plus 8j. Now 6i plus 8j, make it on the x and y coordinates. So you have 6 on the x-axis, 8 on the y-axis. That's the vector you have. So what do we see here? The direction of the vector is same. What has happened? Only the magnitude has increased. All right. Also, you can solve for the rest of the example of in the fx that we saw. When 0 less than k less than 1, you will have any value from 0 to 1. You perform that same thing and the same method, and also make it on the x and y coordinates. So you will be able to understand what is the direction. Direction remains the same, but the length has decreased. Also, make one for k less than 0. So also you will see that the direction has reversed. Okay. So this is how you perform scalar multiplication. This new vector has the same direction as A, but its magnitude is doubled. All right. So that's all for this video. I hope it was clear. These three concepts are very, very important and also very simple. So make sure you like, share, and subscribe to my channel so I'll be able to make more exciting content in much simpler manner. Also, we'll be able to complete all the topics that are going to be asked in applied mathematics. Also, in the future videos, we'll be doing some past paper questions. For now, that's all. In the next video, we'll be talking about unit vectors. So make sure you stay tuned for the next video. And that's all for today. Thank you. Bye bye.